Yeah, Mr. Lee, how extensive can AI help you reduce headcount in your manufacturing environment?
Oh, how extensive the AI can help in the manufacturing plant? Yeah, I suppose it can be a lot or it can be don't know. If you want to know more, yes, let's Sembang AIoT. Hello. Good afternoon, everyone. We started a little bit late today, have got some technical issues. Sorry about that. Thank you for watching. Me, Cecily.
I'm Daniel.
Yeah, very good afternoon. Good day to all of you who are still watching us or still following us in this live channel on the Sembang AIoT. So for those of you who have just started watching us or following us in this Sembang AIoT, of course, we have started until now. This is a episode number 40. Episode number 40. This morning I just got Sembang with another friend, so he asked us, oh, how long already you started? More than 1 year already. I say, no lah, you go and divide lah. 40 divided by 4, meaning 8 months ah. Oh no. 10 months.
10 months.
Yeah, 10 months. not 8 months, 10 months. So how extensive can AI help? Yeah, this is one of the topic I think most of you are very interested, I'm sure. Yeah. So especially for those boss, yeah, 老板们, you sure having a very concern about this issue. Of course, we do this one is not for the sake of Sembang, shock Sembang. So there are a lot of preparation we have to do, yeah, of course. And then I think we, from session number 38 until now, we shift our focus a little bit more in the smart manufacturing side, as we started also because of this is smart manufacturing IR4, and then we started moving into IR4 and IR5. What are the difference? From this the past few sessions, and then followed by we talk about IoT, IoT again, smart factory, digital factory. Digital factory is also a key word in this whole smart manufacturing, where no paper, everything digital. That is how the digital transformation, or how this industrial transformation can take place, where IR4 can put up to the full capacity or full capabilities. Yeah. So you talk about cyber physical system running, every division know each other, data transparency, and so on. So today we come back to this AI again. Of course, why AI? Yeah, why AI? So Ken Leong, I think, asked a very valid question just now. How extensive can you cut down the manpower, or cut down, how AI can replace people? Of course, replacing people is not the nice or correct word to use lah. Yeah, it's not 100% actually. It's actually assisting you to put or to reorganize your manpower or workforce in the different in terms of positioning, in terms of tasks, in terms of role. Yeah, because certain part, if let's say this part can be done by AI, why not? Yeah, so technology is supposed to amplify our efficiency. If let's say you refer to is it Bill Gates or it's no, Microsoft? I think the founder of Microsoft said, and the technology is supposed to amplify the efficiency. Why? Okay, because the sound agree with me on this part. Okay, so talking about AI, I think the very important thing which I think we want Ken Leong to share with me, or to us, to the audience more, is on the deep learning AI. Yeah, without deep learning AI, I think the whole AI still remain as it is. Yeah, of course, AI have done so much. When does this AI being kick-started?
AI, for the very first one is around 1970 something. something.
Yeah, but the original AI, is it not like what we say the other day, 1950 something already, some concept or some paper already published?
Yes, at that time, actually, they already have the idea on how to use the neuron to solve some very complex problem. But at that time, the computer is not so advanced. So because of the limitation of the hardware and also the software at that time, so all this theoretical thing cannot be put into implementation.
Yeah. So because of the computing power, as you know, right now, you refer back, now the computing power, is it at our best? I wouldn't think so. Maybe there are rooms for us to go up some more. But then, of course, this part actually is favoring very much onto the AI field. It help the AI transform or help the AI to propagate further from here. Yeah. So let's go back to the basic of the deep learning, because I was hinted by one of the professor the other day. He sent me some what they call some information on that. This topic on the deep learning is also can be represented by this deep representation. Deep representation, where most of the AI things started from computer vision. Can I say that? It's more image processing. Basically, it's image processing. Because of the image processing that trigger out, how to have a best method of solving the image issue of image problem, recognizing image, spotting image, those kind of things. Yeah, because human being, we are very visual people, so we focus on what we are able to see. So that's why the deep learning, deep representation, basically talking about how the computer vision is able to give you a kind of a deeper understanding or the deeper representation of the image that you are capturing.
Yes.
Or at a different level. Yeah. So in order to have that, that's why deep learning. That's why deep learning. Deep learning. Maybe Wen can give us some kind of introduction about what is the conventional machine learning. We know under the AI field we have this machine learning, we have this deep learning. Yeah, so both of them is subset of this AI. But then what makes the difference of this machine learning and the deep learning? Maybe you can explain.
Okay. So for this computer vision field, your input is an image. So what inside the image is you have the pixel.
Yeah.
So the pixel is your raw data. So if you want a computer to understand this raw data, is something very difficult to do it. So because your raw data, the pixel consists of what? For example, a color image. So you have every pixel has the value from 0 until 255. And then if a color image, you have 3 channels.
RGB.
Okay. So how this number can tell the computer there is an object in the image, or what is the object in the image. So if we just based on this raw pixel, the raw data, it's very hard. So even if a human look at the number, we also don't know all this number representing what. So we need to transform this raw data into a high-level representation. So something that easier for the computer to understand. So okay, now we go back to the machine learning. How the machine learning solve this problem is, so when you're given an input image, so the machine learning algorithm usually they will do the edge detection. So they have an edge detector. So passing through the image to find out the edge of the object in the image. So because the edge is some kind of feature that can help the computer to recognize what are the objects in the image. So the edge is one of the feature. So after that, after we use the edge, then they also have the color, the shape, So all these are considered as a low-level feature. It's not the high-level representation yet.
Yeah.
Okay. And then all these things, it will go into a classifier. So the classifier can be maybe they use the clustering method to do it, or they use the SVM, support vector machine, to classify whether the input image is belong to which class, based on the feature extracted. So this is the machine learning way.
So can I say that the machine learning way, we need a lot of human intervention where you need to do some setting or some what they call marking for this machine learning to learn some of the things that human identify.
Okay. In a more technical terms, is those features are handcrafted feature.
Handcrafted. Yes. Okay.
Handcrafted feature means human need to design the algorithm that able to extract certain edge or certain shape.
In order to well recognize this kind of image,
Yeah.
what kind of representation that's giving to you.
Yeah.
Okay.
So for example, you have an input image, a car. So you need to design an algorithm that can detect the shape of a car. So then you need to start thinking how to write the algorithm, how to write the code, and then car come with different shape. Bus, lorry, van, the sedan, the SUV, MPV, the shape are different. And then the color also different. So, and in order to extract all these features, you need to design a lot of this kind of handcrafted feature.
Right.
So this is the most time-consuming part.
Very time-consuming. Correct.
So, but by using the deep learning, this part is done by the neural network. Neural network will extract this feature by itself without the intervention from human. Human just provide the data set. So in machine learning, we need to think how we're going to extract the feature.
Right.
But in deep learning, we are thinking how we're going to prepare the data set on it.
So basically, deep learning inside, they are methodology, or there are some back-end so-called neuron
Yes.
to interpret from the input to processing to the output. It has its own set of way. I think there are many things going on inside lah. Yeah.
So basically the neural network, they use the convolution layer. Yeah, they use a convolution layer to extract the feature.
Is it because of this convolution level? That's why there's a model called CNN, convolution neural network.
Yes.
All these CNNs come from there, is it?
Yeah.
Okay, that is one of the models that usually used by the image processing people or vision people.
Yeah.
Okay. So that is part of is starting of this neural network. Okay. Okay. So yeah, I hope you guys get what 𝐷𝐽𝐿 had just explained. Basically, why is the difference of the machine learning and this deep learning. Of course, with this deep learning, will you think it is a breakthrough or not? When does this deep learning gets really utilized in the practical world?
Okay, the breakthrough is at the 2012.
Yeah,
at that time they come out with a neural network called
something like
AlexNet.
Oh, AlexNet.
Yeah.
Okay. I also got into some idea where this Alex can come. That is one big breakthrough in terms of image processing using the neural network, right? Okay, that I think is one of the thing. But the whole thing about neural network, because according to some of the vision people who are in the field for a very long time, they will say the problem of deep learning or AI, not able to tell them the reason why this one is like that, why is one that, the result is like that, because inside is too complicated, is it?
Yeah.
Too complicated. So by using the machine learning or their conventional kind of vision algorithm, they know what has gone wrong.
Yes.
Because those are handcrafted, or these are all, a lot of these are human
Controlled by
intervention.
human. Yeah.
So the reasoning is easily achieved. So what do you think about this part? Is it good or bad? Let's say using deep learning, you cannot tell the reason.
Actually, can tell the reason, but you need to go in deep, inspect every layer. What are the output produced at each layer?
I see.
Then you can visualize the features produced at each layer, and you can know those produced features, are they useful for the neural network to make decision?
I see. Okay. So yeah, that first part is about this deep learning. It's because of this deep learning AI. That's why trigger many other applications. For example, the LLM or NLP all come with the deep learning thing, right?
Yes.
Yeah. So yeah, this is a kind of a breakthrough, and then from 2012 you can see things has evolved. Many applications came into picture, but at the same time also when this cloud come into cloud computing or big data come into play, so this one make more and more a possibility in terms of, especially we talk about smart manufacturing, a kind of optimization, quality control, and also what predictive thing, forecasting can be actually driven, more data driven. Yeah, more data driven. That's why, come back to the question again, how extensive can AI help you to reduce a head count? So from vision part of it, from big data part of it, or next time there is a co-pilot, the kind of a knowledge level, you don't need to be so high, but someone will be guided. AI will be guided you. So not so much on cutting down the people, but then with a lower kind of entry level of people who do the same task can be easier, with this data driven or AI driven or AI guided kind of thing. So okay, let's stop about this AI. Now I think we move straight away. Today we actually prepared what they call a conveyor belt. This thing I think we have shown before quite some time ago, but actually we want to go slightly deeper in this level. Maybe we want to just run this demo to you. Yeah, we just run this demo to you. You can take a look. So basically, what do we have for the audience today?
I think we share the screen.
Share the screen.
Yeah. Then the audience will know what we have today.
Okay.
Defect detector.
It's a defect detector.
Yeah, I think they don't know what.
So before we start, so this one will be, let's say in your manufacturing environment, you have something that you need someone to, doing some visual checking. Visual checking, it can be a kind of a PCB board checking, it can be kind of a material checking, or a raw material or something like that, which you use a visual to check, that consume you a lot of time and manpower, that this vision AI is applicable. Let's see how we can do. Yeah. Okay, just blow it up maybe. Okay, maybe you can you run the thing, because whatever you say also we can hear, no problem. Yeah. So on your screen here right now, you can see what? It's a kind of image detector. Is it on the screen right now? You can see in the image detector. And then this, what kind of frame per second, what kind of FPS they are talking about, right now?
Right now, we are running at around 64 FPS.
Yeah, we are running on a 64 frame per second. That means 1 second it is actually captured 64 times. Yeah. So if we are using a simple, just a USB camera, to do this part. Okay. So the left-hand side, what is this left-hand side?
So left-hand side is a SCADA software. So when the AI detects something, it will send the data to the SCADA software, and then we use the SCADA software to present our result.
Okay, basically is those AI data is fed onto the SCADA platform. This is one of the very entry-level SCADA platform where it can capture, it can talk to the AI. We actually make this part, able to talk to the AI so that the SCADA system can present the data more easily. Yeah, in this screen you can see the right-hand side. On the left-hand side, at the bed side, you can see numbers of bed, and this on the left-hand side is the number of goods. Number of goods meaning with the labels, right?
Yeah.
With the labels, yeah. So yeah, this is the whole part about this one. What do you want to tell more about this part,
So this one is using the deep learning. So it's an application of the object detection. So where you can utilize the object detection to perform some defect detection.
Okay, how can we make up to this part? So what are the processes involved?
So the first process is going to collect the data set. So you need to have this kind of environment. So for example, if your product is moving on the conveyor belt, so you need to set up a camera beside your conveyor belt and then start capturing the data. So first step is collect the data set. Then after that, you need to label the data set. So label the data set means for every image that you capture that contain your product, you need to label whether it's a good or a bad sample. Okay. After you finish the labeling, then the third step is the training process. So you're going to select a neural network to start the training. And then after the training finish, so it's the last part, the inference. So we'll deploy the trained neural network in your working environment, and then it will start give you the result.
Okay. So this is a kind of edge AI that we have presented to you, using the live demo here. Of course, it does not need to be, this kind of a label. It can be anything, but we provide you a platform, even without this programming or coding, you are still able to achieve what you want. Maybe we can move on to, is there any more other thing that you want to touch about this part,
Yeah,
no more. Okay, let's move on to the one of my slide there. So we are going to tell you how, just now Ken Leong tell you about, how you can build this AI model from the data entry, data set collecting, training, up to inferencing, up to presenting data to you, to do all kind of automation. This is a part where you need in order to achieve that. So as you know, at Axiomtek, we do have this kind of AIS. It's called AI suite, where it's powered by OpenVINO, right?
Yes.
OpenVINO. And then, of course, inside the OpenVINO thing, the training part, there is a TensorFlow involved in the whole thing. Last time we used to have this, from the beginning last year, end of last year, actually, we tried to talk more about learn and implement using AIoT. That's where one of these AI tools is able to let you build your own AI model and so on, to understand or to perform your own AI data set, or to do your own kind of application. Let's move on to this part. So in this whole thing about this Axiomtek AIS, there's one first part, image capture, data set lah. You're preparing the data set, as what Ken Leong said. The second thing is about labeling. Yeah, these tools allow you to give you to drive you, to provide you a very simple and easy way to label your product, or label data set, where if let's say you want to identify certain thing, the bad spot, you can label those things, and then after that you can do a training. You can see those the small on the right hand low corner there. When it's doing the training, these are the convolution layer. These are the deep learning convolution layer. That's why just now we said in the deep learning it's very hard to tell the reason, but can also say if you go deep enough, you can tell actually what is actually gone wrong. Right? So these are the multiple layers. Some of them is more than 3, 4, 5 layers. Yeah. So it depends on which level. So the accuracy largely depends on the data set, number of data set that you provide. At the same time, also what kind of a model that you use to train. Yeah. After training, the last part is the inferencing. Inferencing meaning is to tell you, like for example, just now we show you the number of count, good count or bad count, that are presented from the inferencing part, where it can do the computer vision at the same time. Inferencing meaning they do the what they call the output. They provide you output. After this layer, they give you output. So what after this output, what you have? You are having a what they call the product count, good or bad, and so on. Yeah, maybe you can move on. So in this whole AI starter kit, or we call last time it's called starter kit but it's already made very practical. You can use. I think if you follow some of our session before, we have this what type of camera it can support. Yeah. So it's actually a complete end-to-end deep learning to the end inferencing tools that we can use that to come up to that stage, to capture the whole AI output. Okay. So of course, in the deployment of AI, actually you do not need, can I say, by using this tool, you do not need to do any coding. You don't need to do any coding. Basically, a web apps design, simple, very intuitive user interface for you to mark or label your this data set. At the same time, also is currently running on the kind of a user interface. It's very intuitive to do that. Maybe you can off the thing. Yeah. So I don't know whether it's at the back there's some background or not. Let's move on. So of course it's powered by OpenVINO and also the TensorFlow, as I told you just now. So in this AI suite, this is a mother of your whole 𝐼𝐴𝐝. Just now you are showing 𝐼𝐴𝐝. This guy on the left hand side is a mother of this AI suite. So you use that to train, you use that to do some proof of concept. Then you can do deployment onto a different platform of the what they call the 𝐼𝐴𝐝 platform. That's where you use that small thing to small system to deploy that into your production floor and so on. This is how the whole concept just now 1, 2, 3, 4, and then plus the final transfer. Then you'll come to that. So let's move on from here. So of course, we covered that in our last session also. This AIS allow you to support how many type of cameras?
3 types. USB camera.
USB camera.
IP camera.
IP camera.
The vision camera.
The industrial vision camera support Gen iCam kind of interface. Okay, you can see on the picture. Let's move on. So of course, at the same time, also in the whole deep learning process, training process, you can bundle or you can put in, or the whole system already come with some standard GPU. These are the GPU that you can use. Right now, you can support up to generation 2, 3, and 4. It will be in the next coming AIS version. So you can use this part in order to speed up your training process. Let's move on from here. So the whole thing, the AIS also support some standard protocol where we have what are the things that we have?
The MQTT,
the
RESTful API.
RESTful API. And OPC UA are all add-on. You can have a OPC UA by using this SCADA, embedded SCADA. You are able to open up the OPC UA. So the integration to PLC also possible. Yeah, integration will possible.
Through the SCADA.
Yeah, through the one of the embedded SCADA platform that is also possible. Okay. In our AIS, we do support the on-board or on-system digital I/O system, where by plugging in one of the isolation I/O, you can use that to do some triggering and also to capture some images, not images, capture some digital input for you to do some triggering, start of a process or end of process or things like that. So that is also possible. It's programmable within the system. Okay. The last part will be you can use some structured programming language, or you can run you can do some scripting that is provided by one of the SCADA platform. Of course, if let's say you are very well trained programmer, you can also use your own C program or Python.
Yeah.
You can also write Python code to escalate or to manipulate some of the AI data that you want. Okay, this is a programming interface. Yeah. So of course, what are the applications in the whole AIS?
So
we
like
can use
just now we show object detection.
Object detection. We can also do classification.
Yes.
Classification, for example, in manufacturing will be what?
Usually we'll use the classification and object detection together.
So that you can do product counting.
Yeah.
You can do product counting, and then you can do a different set of QC inspection, or you want to detect certain event going on.
Yes,
can I say?
can.
I can detect certain event going on. Let's say this event appear, I will start count. How long does the event started, and then how does the event end? It can be, but very seldom people use that method, but then it's possible. It's possible. And then also you can also spot some. You can also use that to do what? Part verification, checking on different model. These are still under classification and object detection as well. So there are many more. There are many more. So these are the set that we have. Maybe we can we can close this part. So yeah. The left-hand side. Okay, while we are waiting for this part to be switched, maybe in the training, deep learning modeling, there is one part of forward propagation and backward propagation. Can you explain a little bit on this part? When we're doing the training, what is this forward propagation?
Okay. Yeah. So from the input image, and then it goes through the entire neural network until the last layer. This process, we call it as a feed-forward propagation, feed-forward process.
Yeah.
So during the training, we have the back propagation, which means at the last layer, after you go through the cost function, you calculate the error, how much is the error, then you have to do the back propagation to update the neuron in each layer. So that next time when the next coming feed forward, it can extract
you can use the previous data.
More better features that can help the entire neural network to identify the object in the image.
That's why I say the deep learning is a breakthrough where it allows different kind of application to be able to make it practical in our daily life. For example, just now whatever we mentioned is these are all CNN, quite usually used model, CNN convolution network, and then there are some these are RNN, recurrent, and also the transformer. Last week you talked about transformer. These are the different model, also deep learning, that allow you to do LLM model, ChatGPT, generative AI will be actually branches from there.
Yes.
Can I say that? Yeah. So I think I hope we haven't gone into deep but then that will actually conclude part of the deep learning, and then we show you how AI is able to help you in, especially on the manufacturing or smart manufacturing environment. What are the challenges, maybe last thing that we can show to this our audience here? What are the challenges in the whole this kind of AI world, or in the, let's say in the manufacturing? What are the challenges you think?
The challenges to implement the AI.
Of course, in terms of R&D, there are different challenges.
Yeah.
Like for example, right now, last week also we shared about unsupervised learning, supervised and unsupervised, what reinforce.
Yeah.
How can those old things be used back, or to further transform or further enhance the AI process? These are the R&D part. What could be other challenges that you have? Let's say you have the last one, maybe you can share.
For the AI, I think it's the first step,
Yeah.
collect data set.
Yeah.
So without having enough number of data set, you cannot have a very good perform neural network.
Correct.
Especially those defect that sometimes maybe 1 month only happen one or twice, but it costs you a very big trouble one.
Yeah. So I think this, whatever Kenneth just said, is very valid. Data set, we cannot run away from data set. 20 years ago, 25 years ago, we collect data, but we don't use it, especially on the machine learning side. Actually, some of the data, whatever's retained in your SCADA system or retained in your historian, maybe that set of data become very valuable right now.
Yes.
It's very valuable. So if you have that in your factory or in your plant, do share with us. We can exchange some idea how you can work further on how you can use this past data to train our AI model to assist you in the later part. Yeah. So is there any more thing that you want to share?
No, we solve the data set problem first.
Solve the data set problem. Of course, data set problem, as you know, we talk AIoT. IoT can be one of the solutions to some of the data. For some are very hard to extract data. IoT solution or IoT system will be able to help you. Yeah. So for those of you who still watching us, thank you very much for watching us. And then we want to end this one with this Sembang bukan seberang Sembang.
Kita Sembang technology.
Kita Sembang AIoT. With that, we want to conclude, and then I will see you in the next coming session. Okay, bye-bye. See you. Thank you.
Bye-bye.